All right, let's start looking at these. So looking at number 1, I want to determine whether or not this factors. So I always do an x. We multiply a and c together up on top. That's what I need my two numbers to multiply to give me. Down on the bottom is where I put b. That's what I need my two numbers to add to give me. And then we have a here, b here, and c here. What is the number in front of my x squared? 1. So up on top I have 1 times another 1. What is 1 times 1? 1. So I need two numbers that multiply to give me 1. It's a pretty short list, right? What numbers multiply to give you 1? What two numbers could we multiply together and get 1? 1 and 1. Or I could multiply -1 with another -1 and get 1. That's it. What do I need this to add to give me? Close. -4. Is there any way that I can take 1 and 1, add them together and get 4, -4? -1 and -1? So does this factor? No, does not factor. It means we're going to go look in Desmos for this. So x squared minus 4x plus 1. I'm going to come over here into Desmos. X squared minus 4x plus 1. Where do I look on the graph for the roots? What am I looking at? Where do I look on the graph for roots? The x-intercepts. Does this graph have x-intercepts? Yes. I see one right here. That's in between what two whole numbers on the x-axis? In between 0 and 1. I see another x-intercept over here. That's in between what two whole numbers? 3 and 4. So on my paper, I'm going to say that there is, from the graph, the roots are between 0 and 1 and between 3 and 4. All right. Let's try number 2. So I'm going to do my x. I need to multiply a and c together. What is a? 2. What is c? What is c? -6. So I multiply a and c together and I get what? -12. I need two numbers that multiply to -12. Are there quite a few numbers that'll do that? All right. I need it to add to give me my b value. What is our b value? +1, because I have a +1x. Can you guys think of two numbers that would multiply to -12, but when I take those same two numbers and add them, I get a +1? -3 and +4. This is going to factor. And if it factors, that means that my roots are going to come out to be either nice, pretty whole numbers, or they're going to be easy to work with fractions. So I'm going to draw my box, because we're going to factor this now. Two x squared goes up here, because that's always where I put my a value. C goes down here, so that's where I put the -6. Those two numbers that we found, the -3 and the +4, go in those two open boxes. It doesn't matter which box I put it in, but I do have to remember to put something with it. I can't just put -3. It has to be -3 what? -3x and a +4x, because when I combine the -3x and the +4x together, it has to give me this middle value. It has to give me my B term. So A goes in the box, C goes in the box, and those two together give me B. All right, let's look for common factors. Looking at these top two boxes, 2x squared and -3x, what do they have in common? They have an x in common. What about down here at the bottom, 4x and -6? What do they have in common? What can I take out of both of them? A 2. +2 or -2? +2 or -2? I thought I heard somebody try to answer, but I didn't hear what they said. Positive, yes. Whatever box it's touching, in this case, it's touching the box with the 4 inside it, whatever sign that is, that's what I have to take out. So since the 4 is positive, I take that positive out with it. So here's one of my factors. That's great. I can use that to find a root. What do I do with my factor if I want to find a root? Set it equal to 0. So x plus 2, I'm going to set that equal to 0. And now I need to solve this for x. What do I need to do to both sides to get x all by itself? Subtract. We're going to -2 from both sides. X equals -2. So we have an x-intercept at -2. All right, let's go vertically now. 2x squared and 4x. What can I take out of both of those? I can take a 2 out. Anything else? Is there anything else that they have in common? 2x. They're both factors of 2, and they both have an x. What about -3x and -6? What can I take out of each of those? -3. I need something that goes into both pieces. And it's going to be a -3 instead of a +3 because the box that it's touching has a negative sign in it. So here's my other factor. 2x minus 3. We're going to set it equal to 0. What do I need to do to get x all by itself? Add 3 to both sides. So I'd have 2x equals 3. And then what do I need to do to both sides? Divide both sides by 2. So x is 3 over 2. Didn't come out to be a whole number, but it did come out to be a nice fraction. All right, number 3. I'm going to make my x. I have to multiply a and c together. What is my a value here? My a value is 3. What's my c value? -1. What do I get when I multiply a and c together? -3. So I need two numbers that multiply to give me -3. What numbers multiply to -3? What multiplies to -3? 1 and -3, or 3 and -1. So 3 and 1, one of them has to be negative. What is my b value? -3. Remember, b value is right here in the middle. That's what we put down here. Can I take 3 and -1, add them together and get -3? Can I take -3 and +1, add them together and get -3? No. So what does that mean about this? Does not factor. So back to our graph. So I'm going to go to Desmos. I'm going to put in 3x squared minus 3x minus 1. Three x squared minus 3x minus 1. Do we have any x-intercepts? Yes. What's it in between? 0 and negative 1 and 1 and 2. Perfect. So the roots are between 0 and negative 1 and between 1 and 2. All right, last one over here. I'm going to make my x. We're going to multiply a and c together. So 2 and 4 get multiplied together. That gives me 8. What's my b value? Negative 9. I need two numbers that multiply to give me a positive 8, but add to give me negative 9. What things can multiply to 8? 4 and 2. Anything else? 1 and 8. Is there any way I could take 4 and 2, add them together, and get negative 9? I can do negative 1 and negative 8. So this one factors. That means I'm going to draw my area model. I'm going to draw the box. My a value goes up here, 2x squared. C value goes down here. There's 4. Negative 1x, negative 8x. And then we start looking at just 2 boxes at a time. 2x squared and negative 1x. What do they have in common? Just x, yes. What about negative 8x and 4? Negative 4. Negative because why? Because it's touching a box that has a negative. So x minus 4 is a factor. We're going to take that and set it equal to 0. To get x all by itself, I add 4 to both sides. So one of my roots is x equals 4. It is the messiest 4 ever. Just for the record, I do not like my new way of writing on the board at all. I feel like my handwriting has gotten much, much messier. All right. 2x squared and negative 8x. What do they have in common? 2x squared and negative 8x. What do they have in common? 2x. What about negative 1x and 4? What do they have in common? Negative 1. Here's my other factor, 2x minus 1. I take that and I set it equal to 0. I'm going to add 1 to both sides. So 2x equals 1. What do I still need to do to get the x all by itself? I am right here. Divide both sides by 2. So x is 1/2. And there's my final answer on that one, 4 and 1/2. All right, let's try some synthetic division now. When I'm doing synthetic division, how do I decide the number that goes in the box? X minus 5, and what do I have to do to this number here? I have to set it equal to 0. So x minus 5 equals 0. I'm going to add 5 to both sides. So x equals 5. That's the number that goes inside the box over here. How do I get the other numbers? Where do I get the other numbers from? Please face forward. This number right here. Where else? Negative 22 and negative 15. So 5, negative 22, negative 15. Draw my equal sign. I usually like to cut this last number off because that's going to be my remainder. What do I do with this first number right here? Bring it straight down. So my 5 comes down. We're going to multiply that with this 5 right here. What is 5 times 5? And I write that here. We're going to add that to the number up above. Negative 22 plus 25, 3. And then I'm going to multiply again. 5 times 3, 15. We're going to add that to the number up above, and we get what? I get a 0 remainder. What do I do with the 5 and the 3 now? What do I need to put with this 5?
X.
An x. So this is going to be 5x. And then that 3 is positive, so plus 3. That would be my final answer here. Number 6, we're going to do very similarly. What number goes in the box? Negative 4. And then I have 3, 14, and negative 12. What happens to my 3? Bring it down. So I have a 3 right here. I multiply negative 4 and 3 together and get what? Negative 12, which I add to the 14 up above. It gives me 2. What is negative 4 times 2? Negative 8. Negative 12 and negative 8. Negative 20. We have a remainder this time. The 3 still gets the x with it. So 3x plus 2. And then I have a remainder of 20. So it's minus 20 over x plus 4. And that x plus 4 is coming from this guy right here. If you have a remainder, it goes over whatever was after your division sign. Let's do number 7. What goes in the box? 6. And then we have 2, negative 7, negative 36, and positive 36. Cut this guy off. 2 comes straight down. 6 times 2 gives me 12. What is negative 7 plus 12? 5. What is 6 times 5? 30. I add that to the negative 36 up above. Negative 6. 6 times negative 6? Negative 36. What's my remainder? 0. So how do I write my final answer then? What do I do with the 2, the 5, and the negative 6?
Oh,
2x squared. What do I do with the 5? Plus 5x minus 6. Final answer. They did not give us a lot of room to do this writing in. Last one, number 8. See if I can't try to make it at least a little bit clearer. What goes inside the box? 3. And then my other numbers are 3, negative 13, 17, negative 18, and 15. Keep my remainder off to the side. 3 comes straight down. I multiply 3 and 3 together and get what? 9. What happens when I add negative 13 and 9 together? Negative 4. Then I'm going to multiply again. 3 times negative 4? Negative 12. And I'm going to add that to the one up above. I get 5. 3 times 5? 15. Add that to the number up above. What do we get? Negative 3. Sorry, just didn't hear you. 3 times negative 3? Negative 9. I add that to the value up above and get a remainder of 6. So let's write our final answer. What do I put with this 3? 3x cubed. Minus 4x what? Squared. Plus 5x minus 3 plus 6. I'm running out of room here now. 6 over x minus 3. Let me see if I can move all of that over just a little bit. Come on. There we go. Plus 6 over x minus 3. There. I made it all fit. All right. Do you guys have any questions for me on the bell work? This is a much longer bell work than we normally do. That was a very long bell work. Our lesson, however, is very short. So we got some trade-offs. Long bell work, short lesson today. For those of you that have not had me in the past, I do post all of my notes on Canvas. So for something like this where we got a whole bunch going on all at once, I will be posting this on Canvas. You guys can find it later as long as you go to today's module. So modules on the left-hand side. Scroll down until you see the 6th, which is the very last module right now. All right, flip in your books to page 299. We're going to talk about some basic operations with functions. We're going to talk about adding, subtracting, multiplying, and dividing. Adding, subtracting, multiplying, and dividing. If you see f and g together inside parentheses with a plus sign, it means they want us to take the function f and add it to the function g. So they have an example over here. F is 3x, g is 2x minus 4. So we take these two, we combine our like terms together. So f of x, this piece right here, they put in right here. G of x, this piece right here, is what they put inside these parentheses here. And then we combine our like terms together. 3x combined with 2x gives us what? Whenever we combine, we're adding. So that gives me 5x when we just put them together. We're just adding these two together. 3x plus 2x. Remember, when I add the numbers in front. My exponents do not change. All right. When we see f minus g, I want to take all of the function f of x, and I'm going to minus the function g of x. So again, my function f of x, that's this piece right here. Notice we have g of x inside parentheses just like we did before. And they said when we combined like terms, I got x plus 4. How is that possible? That's a minus 4 right there. How did they get a plus 4? Yes, we have to distribute our subtraction sign here. They had to distribute here and distribute here. So they had minus 2x plus 4 with that 3x up at the front. And then they combined like terms, 3x minus 2x to get 1x, and then positive 4. So that's adding and subtracting. When you see a filled in dot in between f and g, we're going to multiply those two functions together. So in this case, we're going to take our function f, and we're going to distribute it to our function g. That's how we get 6x squared and then minus 12x. Last but not least is dividing, and then we're going to go in and we're going to practice one of each of these types of problems. F over g means I want to take my function f. It goes up in my numerator. Function g goes in the denominator. But my denominator cannot equal 0. Denominator, please write this down in your notes. It's super, super, super important. Denominator cannot equal 0. So to figure out whatever it is that my denominator is not allowed to be, I'm going to take that function g of x, so in this case 2x minus 4, it cannot be equal to 0. And I'm going to solve this for x just like it was an equal sign. So I'm going to add 4 to both sides. So I get 2x is not equal to 4. And then I'm going to divide both sides by 2. X is not equal to 2. Right here. That's where they got this from. We need to know how to go through that process because with division, we're just going to put our function f over our function g, but then we need to determine what g of x cannot be. What value for x I cannot have there. Guys, I need you facing forward, please. Looking down at the bottom part of page 299, we have our first example. What do they want us to do with these two functions? What operation sign do they have in between the f and the g here? Plus. So we're going to take our function f of x, this one right here. We are going to add that to our function g of x, which is this one right here. So once I know I want f of x plus g of x, f of x is this piece right here. Bring down the plus sign, and then g of x is inside this set of parentheses right here. So after I break it into f of x plus g of x, I do my substitution. I recopy that function f of x in the place of those letters. I recopy my function g of x in the place of these letters. Is there anything in front of this set of parentheses that I need to distribute? Nope. So I can drop those parentheses. What about in front of these parentheses? Do I need to distribute anything? In front of these, do I need to distribute anything? Nope. Or we could say I'm distributing a positive 1. So I recopy that, because if I distribute a positive 1, nothing changes. I can't stop here because there's some like terms that I can combine together. Negative 5 and 1. What do I get when I combine negative 5 and 1 together? Negative 4. That's going to go at the end. That's my constant. The x squareds, negative x squared and 2x squared. What do I get when I combine those together? I just get an x squared. That's this piece right here. Does the 3x have a like term? Then that just comes down as part of my final answer. Here's my final answer. To get to the next one, to get to part B, you're going to have to turn the page. It's at the top of the next page. What operation are they asking me to do now? Subtraction. We are supposed to subtract function f and function g. So we're going to take f of x. It's on the previous page for you, but I have the numbers for f of x still up at the top. That function f of x is equal to what? What can I put in its place? What am I going to substitute in for f of x? Negative x squared plus 3x plus what? 1. We're doing f of x minus g of x. Notice this part also goes inside parentheses here. What do I need to do here? Do I need to distribute anything to the first set of parentheses? No. Do I need to distribute anything to the second set of parentheses? What do I need to distribute there? The negative. So I distribute this. That gives me negative 2x squared and I distribute back here. What is a negative times a negative? Positive. So that they recopied right down here. Are there any like terms at all that we can combine together? Yeah. What can I combine? 1 and 5. The 1 and the 5. What does 1 and 5 combine to give me? 6. That's going to go at the back here because that's my constant. Is there anything else that I can combine? Negative x squared, negative 2x. How many negative x squareds is that? This one right here. I have a 1, so negative 1x squared and negative 2x squared. What do I get when I put those together? Negative 3x squared. Do I have a like term for this one? No. Nope, so bring it down. That would be my final answer. All right. So adding two functions together, subtracting two functions. Do you guys have any questions for me about that piece before we talk about multiplication or division? No? Okay. Let's go look at the second example. We're going to multiply and divide. I know your book has a bunch of things filled in. I like some of the ways your book does it. I don't like some of the other ways your book does it. So I'm going to work it out here. You guys have some extra space off to the side because they don't show you where they're getting some of their numbers from. So we're going to do some process work off to the side. What does that dot mean again? It means multiplication. What things am I supposed to be multiplying together? Yes, my function f of x, which you just said was 4x squared minus 2x plus 3. Inside parentheses. Anytime I make a substitution, it goes inside parentheses. I'm going to multiply that to what other function? Yes, my function g of x, which is negative x plus 5. Those of you that had me last semester, when we had a multiplication problem like this, when I had a trinomial, a 3-term polynomial, multiplied by a 2-term polynomial, we drew a rectangle. Your book does not show how they're multiplying this together, so I would put this off in the margin. One of my polynomials has 3 terms, so one of the sides of my rectangle gets cut into 3 parts. And I put one piece, one term, above each section. The other polynomial, g of x, has how many terms? 2. So I'm going to take the other side of my rectangle and cut it into how many parts? 2 parts. And I put one term with each of those pieces. So I have negative x and positive 5. So far, so good? I'm going to see if I can't make that just a little bit larger. There we go. A little bit bigger for us. I'm going to take this negative x right here, and I'm going to multiply it to each one of these terms up on top. And I'm going to put the answer in these top boxes. So I do negative x times 4x squared. What is negative x times 4x squared? Negative 4x cubed. And then I do the same thing with the next term. Negative x times negative 2x. What's a negative times a negative? Positive. So I get a positive what? 2x squared. Negative x times positive 3 is what? Negative 3x, yes. All right. So we took this negative x, we distributed it to each piece. I'm going to do the exact same thing with the 5 that's down on the bottom. I'm going to take this 5 and distribute it to the 4x squared. What is 5 times 4x squared? 20x squared. 5 times negative 2x? Negative 10x. And 5 times 3? 15. Here's one of the biggest reasons why I like doing it this way. Not only did I make sure to do all the distribution that I need to do, and I know that because every single box is filled in, but when I go to combine my like terms are located on these diagonals here. 20x squared and 2x squared are like terms that are going to combine together. Are there any other like terms that will combine together here? Negative 3x and negative 10x are going to combine together. So let's write down our final answer now. Is there a like term for negative 4x cubed? Nope, so I just recopy that. Negative 4x cubed. I'm going to combine my x squareds together and get what?
22x.
Plus 22x squared. And then I combine my x's together and get what? Negative 13x. Am I done? What else do I need? Plus 15. Don't forget that constant. That would be my final answer right there. What operation are they asking me to do in part B? This is the last thing that we're doing today. Division. Which function, f or g, is supposed to go up in my numerator? Is f or g supposed to go in the numerator? F. F is in the numerator here. So I have f of x in the numerator here. G is down on bottom here. So we have g on the bottom here. Remember, g of x is not allowed to be equal to what? 0. Why is that again? Can't have 0 where in my fraction? In the denominator. No zeros on the bottom. You cannot divide by 0. All right, f of x goes up on top. What is my function f of x? What numbers and letters am I putting in for f of x? 4x squared minus 2x plus 3 over what? Negative x plus 5. That's all I need to write for that part of it. But we have to figure out what x is not allowed to be equal to. How do I figure that out again? Make what equal to 0? Yep, the denominator. So I take negative x plus 5. This is not allowed to be equal to 0. I'm going to minus 5 from both sides. So negative x is not allowed to be equal to negative 5. What do I need to do yet to get the x all by itself? Divide by negative 1, yes. What is negative 5 divided by negative 1? What is negative 5 divided by negative 1? 5. X is not allowed to be equal to 5. And now I have the rest of my answer. There is one more operation that we are going to talk about on Monday. It's an operation that you guys have never been introduced to before. We did adding, subtracting, multiplying, and dividing today. On Monday, we're going to cover something called composition. We're going to compose f and g together. Your homework assignment, 6.1 homework. You can access this from Canvas, or you can go through Clever to McGraw-Hill, 6.1 homework. One thing I want to warn you guys about, though. We have not done any problems that have this notation. How is that different looking from multiplication? How is that different looking than multiplication? Yeah, multiplication would look like this. If it is an open circle, that is the new operation that we have not learned about yet. This is composition. And we will learn about that on Monday. So if you start on the homework, any problems that have this, we have not learned how to do yet. We've only learned how to do adding, subtracting, multiplying, and dividing. If you prefer to work it out on paper first before you put your answers into Canvas, these are the problem numbers from the book for that Canvas assignment. But you will turn in your homework to me on Canvas, not on paper. I give you guys the problem numbers in the book so that you can go ahead and work on those particular pieces. Ask questions if you run into problems, or you can bring your book up to me and ask questions during our D-Lunch study time. Do you guys have any questions for me at all? All right. I hope that you guys have a fantastic